Welcome back to EE-Craft. In earlier tutorials, we explored two powerful sensors, the BME280, which measures temperature, pressure, and humidity, and the SGP40, which detects VOC for air quality. These videos gave us the building blocks to understand environmental sensing. The link of these videos are provided in the description box for your reference, in case you want to refresh your knowledge on these two sensors. Today, we're going to combine that knowledge with the Arduino UNO R4 WiFi and push real-time data to the cloud for live dashboards. If you haven't seen those sensor basics yet, check out the BME280 and SGP40 videos on EE-Craft, and then join me here as we build a complete IoT workflow from sensor to cloud visualization. In this tutorial, we'll explore how to use MathWorks' ThingSpeak cloud platform, which makes it easy to collect, store, and visualize sensor data in real time. The hardware setup is simple. We are using an Arduino UNO R4 Wi-Fi board as the main controller. To measure environmental parameters, we connect a BME280 breakout board, and for air quality monitoring we add an SGP40 sensor breakout board. Both sensors are mounted on a general-purpose PCB, which allows us to neatly wire them together and connect them to the I2C bus of the Arduino UNO board. The I2C connections include SDA and SCL lines, along with power and ground. A regulated 3.3 V supply is provided directly from the Arduino connector to power the sensors. This compact setup makes it easy to integrate multiple sensors into a single IoT project. The Arduino sketch is also a simple one. We begin by including the necessary libraries: WiFi-3 for network connectivity, Arduino HTTP client for sending data to the cloud, and the sensor libraries for the SGP40 and BME280. These libraries provide the functions we need to talk to the hardware. Next, we define the Wi-Fi credentials and the ThingSpeak server details. This allows the board to connect to the Internet. The next few lines of codes before the setup function create a communication channel with the ThingSpeak server over Wi-Fi. In the setup function, we initialize both sensors. If either sensor fails to respond, the sketch halts with an error message. Ensure you use the correct I2C addresses and replace the Wi-Fi credentials with your own. Inside the loop function, we continuously read values from the sensors. The SGP40 gives us a VOC index, compensated by the temperature and RH readings from the BME280 sensor. Also replace the write API key after you set up your channel. We pass the temp and RH values to get the accurate AQI from the SGP40 sensor. For a deeper understanding of how relative humidity and temperature influence VOC index accuracy, you can consult the Sensorion SGP40 datasheet, which explains the benefits of applying environmental compensation during calculation. We then construct a string of data fields to send to ThingSpeak. Field 1 is VOC index, Field 2 is relative humidity, and Field 3 is temperature. This structured format ensures that ThingSpeak knows exactly how to plot each parameter on its dashboard. Using the HTTP client, we post the data to ThingSpeak's update endpoint. The server responds with a status code, which we print to the serial monitor. A status of 200 means success. Your data has reached the cloud. At the end, we add a delay of 1 minute between reading. To begin with setting up the channel, create a free ThingSpeak MathWorks account. You'll need to provide a valid email address, set a password, and confirm your registration. Once you log in, you'll have access to the ThingSpeak dashboard, which is where all your IoT channels and data visualization tools are managed. From the dashboard, select Channels, My Channels, New Channel. This opens a form where you can define the details of your project. Give the channel a descriptive name, in our case, Indoor Air Quality. This name will help you organize and identify your data streams later. ThingSpeak lets you create multiple fields within a channel, with each field representing a different sensor measurement. In this project, we'll set up 3 fields: VOC index, relative humidity, and temperature in the same order as defined in the Arduino sketch. Rest of the fields are optional. After entering the channel name and field labels, click Save Channel. ThingSpeak will generate a unique channel ID and API keys. These keys are essential. They allow your Arduino sketch to send data securely to your channel. Once saved, you'll see an empty dashboard with placeholders for your graphs. Since I already created the channel and the Arduino is doing its job perfectly, we are able to visualize the data. Apart from the live visualization, we can also export the data and download the same in convenient formats. This site provides a helpful tutorial you can follow to learn more about creating channels. In addition, you may find some of the example IoT projects shared there useful for exploring practical applications. As soon as your Arduino UNO R4 starts posting data, ThingSpeak will automatically plot the values of VOC Index, relative humidity, and temperature in real time. You can customize the graphs, add widgets, or even share the channel publicly if you want others to view your results. Thank you for joining me on this indoor air quality IoT project. We explored how the Arduino UNO R4 Wi-Fi connects with the SGP40 and BME280 sensors, and how their data can be visualized in real time on the cloud. This workflow, from sensors to dashboards, shows the power of IoT in everyday applications. If you enjoyed this tutorial, don't forget to subscribe to EE Craft for more hands-on projects and practical electronics learning. Thank you for watching and see you in the next video.